Okay, let's take a look at this problem and see if we can get it to work using our trig substitution. So I'm going to go ahead and label my angle theta here. And since we apparently have a sum of squares, I'm going to go ahead and use tangent. So let's say let tangent of theta be what I'm squaring variable-wise. Well, if I think about x to the sixth being something or some quantity squared, that would be x cubed. So I'll say that's my numerator over what you're squaring with your constant, and that would be a 4. So since I'm using SOHCAHTOA, I'll label my right triangle accordingly. So let tangent of theta be x cubed. This should be my opposite side. And my adjacent should be 4. Then go ahead and spend a minute using Pythagorean theorem to make sure that when you solve for this hypotenuse, you do in fact get the square root of the quantity x to the sixth plus 16. We have to make sure that those match. All right, now that I have that, let tangent of theta equals x cubed over 4. Go ahead and multiply both sides by 4. So here's what it is in terms of x cubed. Don't worry about that x cubed so much yet. Go ahead and take the derivative, just like we've done before. So 4 secant squared theta d theta equals 3x squared dx. Now, just go ahead and take a look at your problem real quick and see if you think this is going to work. So look ahead. Well, I believe so because this x squared is going to match really well with that. So let's just go ahead. A lot of you are solving for dx, so go ahead and do that. 4 secant squared theta d theta, and this would be all divided by 3x squared. Now, I know we're in single variable calculus. Don't worry so much yet about the fact that you have thetas and x's. They are going to divide on the very next step like so. Let me substitute everything in. For 1 second here, I'm going to have that x squared still in my numerator. But in my denominator, I'm going to have x to the sixth plus 16. Well, under that square root, well, really, it's x to the sixth, which is x cubed squared. So this would be the 4 tangent of theta squared plus that 16. Right? Because if x cubed is 4 tangent theta, that means 4 tangent theta quantity squared is x to the sixth, because you can square both sides. And then times dx, which I have in green above here. Okay. So maybe now you see why I wasn't too worried about those x squareds. They do divide to 1. I'm going to pull all my coefficients off at the same time, so forgive me for just a minute. Those are going to stay underneath your square root. You do have 16 tangent squared theta plus 16. So I will rewrite this a little bit neater. Because under the square root, I do have, I'll factor out a 16. And, sorry, it's not an S. I have tangent squared theta plus 1. And then that's it. Okay. Did I copy everything? 4 secant squared theta d theta? Yes. Oh, I forgot the 3. See that little 3 right there? So I need that 3 for sure. So I'll put it right here. Okay, so now if I look at this, I can keep going. By our Pythagorean identity here, tangent squared of theta plus 1 is secant squared theta. So I will do this one kind of step at a time here. So this is 16 secant squared theta. And here's the good news. This makes 4 secant theta, right? Because I could take the square root of one term at a time. So now I have 4/3. I'll divide the 4s. So I'm going to bring out only a 1/3. And I have secant squared theta over secant theta. It'll leave 1 secant theta d theta. Everything else has been accounted for. So if I look at this, again, that secant squared theta divided by secant theta will divide out into just secant theta. And I had 4 over 4 divided to 1. but I do have that 1/3 left over there. Okay, well, I know what this integrates to. This is 1/3 natural log of absolute value, secant theta plus tangent theta. And if I don't have bounds, I certainly have that plus c for that indefinite integral. And I'm going to go right back to my triangle where I started the problem, and I'm going to write my answer here, just copying this down. Okay, and now I'm going to use the triangle to finish my problem or to answer the question here. So secant of theta, well, that's just a reciprocal of cosine. So my final answer will be, if it's reciprocal of cosine, it'll be hypotenuse over adjacent. So look at your triangle. My hypotenuse is the square root of the quantity x to the 6 plus 16. My adjacent side was 4. And then I have plus tangent of theta. Tangent of theta would be opposite over adjacent. Think of SOHCAHTOA. So opposite of my theta is the x cubed, and adjacent is the 4. I'm done. So I hope you found this video helpful. There are more at PVCC Jen Henderson on the YouTube channel, but hopefully you found this trig substitution helpful. And again, there are other ways to do it, but I think this trig sub was pretty straightforward. Thanks for watching.